Okay, let's have a look at all the little engineering knickknacks and curiosities that I've collected over the years and gathered around my desk. Let's start over here. When people first come in through the main door here, this is the first thing they see. I got all these things lined up here. I guess I'll start right here. This is just a little LED light chaser circuit I made back in 2004. Just uses 555 timer and some 7400 series logic to get it going back and forth like that. Up here's another one I made quite recently. I made it Jim Williams style, with everything, all the parts all out in the open like that. I'm using a CD 4017 counter chip right there, decade counter with some transistor astable multivibrator, and going to some more transistor drivers here to light up the LEDs. And down here, when I first started working here, I came across a whole bunch of obscure transistors and semiconductors and different packages and such, and so I made kind of like a little scene that you might see in a David Attenborough documentary. The story that I've created here is that this is the predator right here, and everything else is a whole family of bugs, with the male that's already been killed, and you can see how its legs are all folded up as insects do. And then there's the female here. You can see she's rearing up on her legs, and she got her little pinchers out trying to scare away the predator, and she's doing that to protect her three little babies back here. Very cute. Here's a little 3D printed robot that somebody made for me. This is something I made quite a ways back. Just a little 3 inductor package, little transformer thing or something. Stat tran, 3 millihenry with a 4:1:4 ratio. But you can see I made a little dog out of it, and his name is Henry, named after Joseph Henry. Then there's the rotor and the stator out of a Synchro resolver. We've got some print heads from a certain kind of IBM printer. I forget what it is, but I stacked them all on a bolt right here. Got some high voltage vacuum tubes, 1B3GT. They have a 26 kV rating. I got these out of a high voltage power supply. And these two little tubes are from some kind of high frequency piece of equipment that I took apart. What is it? It's an HP, oh there we go, 6DZ4 or 6AF4A. And yeah, I got half of a coil, a deflection coil for a CRT from a computer monitor. Here's some RF chokes, high frequency, high voltage RF chokes. I used to have a lot of electrolytic can capacitors, and I threw away all of them except this one because this is the most colorful. It's got this nice red and blue label printed on it. Got some different obscure steel motor cores here, and here's another little doohickey thing I took out of some motor I took apart. I think this came out of a much larger motor, but this particular part of it was probably meant to be a tachometer, a little electromagnetic tachometer to output certain pulses to monitor the speed of the motor. And then here, here we've got this one and one over here with another motor core on top there. some big, ginormous springs that I took out of the top lid from an old copy machine that I took apart back in 2006. And this contraption right here, this is a 300 watt projector lamp, and I have it just suspended on this springy insulated copper wire, and got the current going through a couple of capacitors in parallel here just to limit the current. So normally it would have 120 volts across the lamp, but as it is, there's only 20 volts, and so that's why the filament is quite dim and exceptionally long lasting. I've had it going for about a month now, and I expect it to continue to be lit up like this for many years. Up here we got some little springy things from different clock mechanisms or wind-up things I've taken apart. And right here, these two things, these are the tuning selector coils from a couple of old TVs I took apart. These would be for the UHF band from channels 2 to 13. So for each channel, these things would be, all these contacts would be making contact with certain contacts inside a steel box about that big, enclosing it, and make, different, basically selecting all these different inductances for different tuning circuits to tune in a certain channel. Right here we got some laser diode polyhedra that I put together. When I first came here, I found a bunch of these little laser diodes. At least I assume they're laser diodes. There really is no markings on them to speak of. They're completely empty. So I didn't even bother trying to hook them up to a power supply at the time. I had no idea how to figure out how to drive a laser diode, so I just put them together like this. Make some nice ornaments. And then right here, of course, we've got the plastic film, each side of it from a keyboard that I've taken apart. I thought it would be nice to put this up so you can kind of see through it and also see all the really cool circuit board looking traces on here. And then this is a grouping of little tiny light bulbs that I've put together in such a way to make a cube shape, basically, with some extra light bulbs in the center. And I've got a picture here, a schematic. So that's really what it looks like. There's 3 parallel pairs up there and 3 parallel pairs on the bottom, and then 6 individual light bulbs in the middle. But you can see the cube shape right there, and wire on the bottom, wire on the top. Just have it going, looping all around here, and powered by a 12-volt battery. I don't have this on most of the time, just once in a while is when I turn it on. But anyway, with this kind of circuit, theoretically, if each light bulb has the same resistance, then each one will have the exact same current and the exact same brightness. Now coming over to the other side of my desk here, I've got this really old school lamp, probably from the 60s, maybe the 50s, I'm not entirely sure. It's got the nice articulated arm and everything. So I use it when I need it. Most of the time the lamp, the fluorescent fixture right above my desk is good enough. Here's my neon flicker flame lamp. I've got it in the fixture with a little concave mirror right behind it, so when I'm sitting here I can just enjoy its flickering neon glow once in a while when I look up. Got a hockey puck rectifier. And then there's this little induction tuning selector thing. I just took a break from my video to try to figure out where I got it from, and I just remembered that it's from an HP 3200B VHF oscillator. You can see here there's large inductance for lower frequencies and then increasingly less inductance. There's a single loop of wire on here, and then this one just has pretty almost at DC, practically a short circuit, but at high frequency. And this VHF oscillator thing, that would certainly have some amount of inductance between these two terminals. And consequently, that's the same thing that these two small tubes came out of. And I also have, not on display, I just pulled it out of a cabinet, the power supply board from that thing. And I keep this because it's a nice example of how there was a time in equipment engineering when tubes and transistors worked hand in hand. So you can see there's a 0A2 voltage regulator tube right here, and we've got a few other transistors on board, little dinky small signal ones, and some big power transistors here too. And this thing looks like early 70s. You can see there's a date code 7249 on that transistor. This one down here is 7252, and the tube itself is from 1973. Coming back up here, we got the spindle from a hard drive. It must have taken apart a long time ago. This came out of a dot matrix printer. This is the thing where all the pins would have been on the end of each one of these little arms sticking up, and then aligned through a series of holes, and there was a whole bunch of an individual electromagnet for each one of these arms to actuate the pins. But that's all gone. I just have this leftover disc remaining. It's very pretty. I took apart some old Tektronix scopes years ago, so I got the precision capacitors that were in here for different time bases, I suppose. This one has a tolerance of 1/4%. And there's this nice finished block of aluminum here. Got a fuse, and I've got lots of these fuses though, but I got this one out because it has this little tiny cup on it, so I keep this little glass ball from a Ramune soft drink container. Then we got some other large inductor selection wheels. I got these out of an HP 250B RX meter. A really huge thing. When I took it apart, it was a vacuum tube RX meter. And here's the other one. These things would just spin around for different tuning frequencies, I guess, and there's the contacts right there to go into the different tuning circuits. And we got a whole bunch of gears, big and small. This particular gear here, this came out of the crankshaft from a telephone, where you'd have to turn the handle in order to generate a high enough voltage to ring the bells on the other end of the line. And then we got some other things. I took apart an SCR once, big high power SCR, just to see what kind of semiconductor was inside of it. And so here it is. Let's see, this came out of a GEC C152P, 1000 volt, 70 amp rating. And all the contacts are concentric. You can see right in the middle, that's probably going to be the gate. And then this one and that one are either going to be the anode cathode or cathode anode. I don't remember which way it was. And we got some more gears and little mechanical doohickeys I've collected over the years. I like this. This looks like Magneto's helmet that he wears, and then there's this little brass top hat. You can play Monopoly with that thing. Thin sliver of a railroad rail. We got a GE Thyrite resistor. It's made of a ceramic material. It has a nonlinear characteristic such that at higher voltages it has less resistance, and so it's used or at least it used to be used as a lightning protection device. So at 120 or 250 volts or whatever, it has high impedance, but if you increase it to 1000 volts or more, it has very low impedance, which gets shunted to ground. Here's some other things. No, this is not the barrel from a 6-shooter gun. This is the barrel from a high frequency impedance selector. And you can see these were the actual impedances that were inside, these little resistor networks. Each little black bar is a resistor, and each disc is a resistor too. It has resistance from the center axis to the outside ring. It's very evenly spaced all around. And we got one right here, that's a short circuit. And we got some other motor stuff here, some rotors, and this came out of this, which was a power activated relay. See, it had current coils here and voltage coils down here. So under a certain amount of voltage and a certain amount of power, then the shaft would rotate one way or the other. And it wouldn't go all the way around. It was not designed to be a motor, just a little bit of rotation to switch some contacts that were mounted on the shaft. And then here, just attached with the magnet, is an inductor and a light bulb up here, a 10 watt light bulb, 120 volt, but with the inductor in series it's only getting about 60 volts. And I've had this going for a good number of years now, probably my guess is 4 or 5 years, and it's been lit almost continuously ever since then, and it's still going. Although the filament is showing spots. I don't know if the camera's going to focus on here or if you can actually see that, but there are certain areas where the filament is brighter and darker, and so it's definitely degrading, but at a very slow rate. And right here, I just keep this as a friendly reminder of the upcoming total solar eclipse in 2017, August 21st. It's going to traverse across the whole continental U.S. from Oregon to South Carolina. So when that happens, I'll probably be going down to South Carolina to see the solar eclipse. And then up here is a 24-hour timer that I've converted into a 24-hour clock. But in this case, I don't divide the day into 24 hours. I divide it into 10 decimal hours. So 0 would be 12 midnight, and then 5 on this, that's 12 noon. And so basically it's metric time. You can see right now it's about 0.74 through the day. If the whole day is 1, then we're at 0.74. 0.75 would be 6 p.m. And so you can see that we are indeed almost at 6 p.m. Back down here on the bottom shelf now, there's this flashlight that I made. Let me put, it's just a block of wood, and I drilled a hole for this thing. I mean, this thing used to be on top of another battery case, just like a regular flashlight like this would be, but I never had that, so I put these 2 batteries in a piece of wood here, and I make all these connections with magnets and wires. And then the light bulb itself, if I can get this thing to turn on, there we go. It makes a very fine beam. Even though it's dim, it's still, if I'm in a dark room and I need to do some weird photography thing where I just want to illuminate a very fine spot on the other end of the room, like I actually did with my Tesla coil stuff, that's why I made it in the first place, then I can do that. It's got a nice articulating arm here and big thick lens on the cap, and the light bulb itself is just little tiny thing like this. Also on display, I've got my sexy transformer that I took out of a CD clock radio thing, and General Electric Little dinky itty bitty baby motor. Isn't it cute? It looks just like a really big one, except it's tiny. And here's my collection of floppy disk rings. The center ring that would catch onto the spindle on the floppy disk drive and make it spin. I've taken apart a lot of floppy disks over the years. Obviously, it's probably taken me 15 years to collect all these things. And some more computer memorabilia here. Mouse balls. Lots of mouse balls. Here's the a magnetron that I cut it open and I soldered the top of it here to its side just to keep it on and maintain all the connections. You can see how one of these pieces sticking out of the wall here, that goes to the microwave output up here. And the filament, if you can see it, is still intact. It's very nice clean copper. Then we got some other collections of steel ball bearings here, lots of different sizes. This little thing here, this is a vacuum tube filament transformer, which I have repurposed as both the transformer and a nice sturdy base for this little light bulb flashy thing. I don't know where I got these light bulbs from, but they're the typical flasher bulbs that you would have in a Christmas light string, except of course these are much bigger, and screw base. So I just turn this on once in a while and let them flash. There's a little switch in the back there. Little dinky alarm clock. It's not even a clock radio, it just goes beep 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 when the alarm goes off, but I don't ever use it for the alarm, it's just for time. And got this really badass magnet right here. My high school physics teacher used to have a magnet like this, and he would use it to demonstrate Lenz's law by dropping a sheet of copper through it like that. And so when I first started working here, I was very pleased to get something like this and be able to play around with it a little bit more. And here's another badass strong magnet. This is my paperclip magnet. I've been putting paper clips on it all the time, and it's so freaking strong. I could be sitting at my desk and I don't need to put a paper clip right up to it. I can just toss it from a distance and they always stick to it. Finally, way up top here, we got all these little tiny D'Arsonval galvanometer movements. Well, most of them are D'Arsonval. Some of them are moving iron vane, like this one, and a few others that I have up here. There's one, there's another. But I've taken apart a lot of galvanometers over the years. Most galvanometers, or any kind of analog meter, I normally wouldn't take apart unless it was broken or if it was a cheap piece of crap. And so that's where I got most of these from. These are all hanging by their original spring-loaded wires and their original hardware here that the wire was originally attached to. A few years ago I took a bunch of these and I made a mobile out of them. Here's some pictures of it. And someday soon I hope to make some more mobiles out of all these other little things here. And then finally got some other miscellaneous analog meter hardware up here. These things, these two things, where it came out of the type of analog meter where the needle goes, instead of just like 90 or 100 degrees, it goes a full 300 degrees all the way around, about 300 or 270 degrees or something like that, but much wider range with this particular kind of iron core and a certain type of coil. If I can find one here. Here we go. This is a fine example. where the axis goes right down one side of the coil, unlike all these others where the axis goes through the middle of the coil. Here the coil is offset to one side, and so that's how it's able to go a much wider range from here all the way over to there. So that's it for my little lab tour here of engineering doohickeys around my desk. I'll have lots more videos to come about other stuff, other parts and equipment, some of which is quite common, some of which is quite obscure. Stay tuned.